Let's take this problem so that you will be able to understand the concept very clearly. Okay, they have given the process IDs or process number, then they have given the arrival time and burst time. They have also given something called as time quantum equal to 2 time units. Okay, which we don't see in other scheduling algorithms, right? This is the first time we are seeing, because only in round robin they will give time quantum, and without giving time quantum it is not possible to actually apply round robin scheduling algorithm. Okay, fine. Time quantum equal to 2 time units. Now let's start our Gantt chart. Okay, this is a queue and this is a Gantt chart. Okay, don't get confused. We are starting our Gantt chart at time unit 0 as usual. Fine. Now at time unit 0, the only process which has arrived to the RAM is P1. Okay, so no other way. What we will be doing is, see, any process which has come to the RAM, we will be placing it inside the queue. Okay, so I have placed the process P1. Only P1 has come at time unit 0. So I have placed process P1. Okay. Now whenever I want to schedule a process, what I should be doing is I need to remove from the queue. Okay. See, insertion will happen only at the rear end, whereas deletion will always happen only at the front end. Okay. Now P1 will be removed and P1 will be scheduled. Okay. And it can run for at max 2 time units. Okay. Now let us assume it executes till 2. Now what will happen is this 4 will become 2 because 2 time units have been already executed, right? Fine. Now at time unit 2, both P2 has arrived as well as P3 has arrived, okay? Right? So see, one thing is for sure. P1 has not completed its execution, right? Because it needs 2 more time units from the CPU in order to complete its execution. So definitely we need to place P1 inside the queue. Why? Because in order to complete, see, we will always execute a process or schedule a process only after deleting it from the queue. For example, here we have deleted P1 and then we have scheduled P1. Now in case if I wanted to schedule P1 further after some time, I might have to the P1 has to be inside the queue. Okay, so we schedule a process by deleting it from the queue, which means we delete it from the queue and then we schedule it. Now P1 has to be scheduled after some time because it needs to complete its execution of further 2 time units, right? So we need to definitely place P1 inside the queue for sure. But keep one point in mind, that the process which is coming new, as of now P2 and P3 has come in this time interval, right? They have to be placed in the queue first, which means newer process has to be given the chance first, okay, to the CPU. The newer processor process P2 and then P3 in that order, okay, because P2 came first and then P3 came. See, P1 has already got a chance, okay, P1 has already got a chance from the CPU. So P1 is not a new process, whereas P2 and P3 has not got a chance so far. They are new processors, which means they are coming into the RAM for the first time. So P2 and P3 have to be given the first chance. Only after that P1 should be pushed into the queue. See, the order in which we push into the queue really matters, because in here I have inserted P2 followed by P3 followed by P1, and so P2 will get the CPU before P3 and P3 will get the CPU before P1. In case if I would have inserted in a different way like P1, P2, P3, it is actually wrong. Okay, that is what I wanted to mention here. We always push the newer process. We always try to give chance for the new process. Only after that we will give chance for the process which has already got a chance from the CPU, which has already got a chance. P1 has already completed its execution once, right? For some time, not completed, it has executed for some time, which means it has used the CPU for some time, right? Fine. So time unit 2, until time unit 2, both P2 and P3 has come, we have pushed into the queue, fine, and P1 has not completed its execution, that's why we have pushed P1, right? In case P1 has completed its execution, we would not have pushed P1, okay? Since P1 has not completed its execution, we have pushed P1 as well, fine. Now what will happen is, as usual, I have already told that in order to schedule a process, we should always remove from the queue and then schedule it. Now P2, when we always remove from the front of the queue. Now P2 is at the front of the queue, right? So P2 will be removed and P2 will be scheduled. It will again execute for 2 time units because our time quantum equal to 2. Fine. So what will happen is P2 will become 3 because 2 time units have been already executed. Fine. Now until time unit 4, P4 has arrived to the RAM and P5 has arrived to the RAM, right? So initially we will be pushing both P4 and then P5. After that we will be pushing process P2 because P2 has not completed its execution. Okay, so we will push P2 as well. Fine. Now what we will be doing is we will again remove from the queue, from the front of the queue, and then we will schedule it, and P3 will execute till 6, and so this will become 0. Now watch this closely. Process P3 has completed its execution, right? So I don't need to push process P3 into the queue. It is not necessary because it has already completed its execution. There is no point in pushing it into the queue, right? In case if you push process P3 into the queue, what will happen is again it will be removed and then it will be scheduled, which we don't want because P3 has completed its execution. Fine. Now we have actually now we have actually scheduled process P3. Fine, and we have decreased 2 time units. Fine. Now until from in the duration from 4 to 6 processes, both P5 has already arrived. Fine, P6 has arrived, right? So P6 has to be pushed into the queue. Okay, I'm not pushing P3. Okay, I'm not inserting P3. Keep that point in mind. Fine. Now what I should do? I should again remove from the queue and then schedule it, and then it will execute till 8, and P1 will become 0. Now P1 has also completed its execution, so we don't need to insert P1 further into the queue. It is not necessary. Okay. Now in the duration from 6 to 8, has any process come? Nothing, right? Already every process has actually come before itself. So we don't need to push any process into the queue. It's not necessary, right? Fine. Now what we will do? We will actually remove P4 and then schedule P4. It will run till 10. So P1, actually here we don't need to run till 10 because P4 needs only one time unit from the CPU, right? There is no point in running P4 for 2 time units. So we will run for only one time unit. That is the reason we have set maximum allowable time. Okay, time quantum is the maximum amount of time. It can be less than time quantum as well. Here time quantum equal to 2, but still we are running for only time unit because process P4 needs only one time unit in order to complete its execution. Okay, fine. Now we have actually completed process P4, right? Yes, we have completed process P4, so we can leave it as it is. Now what we will do is we will again remove P5 and then schedule P5. So P5 will actually run till 11, right? Till 11 time unit. Fine. Now P5 is done. Fine. Now P5 will become 4. Okay. Now what will happen is we will remove P2 and then we will schedule it. It will run till 13. So P2 will become 1. Fine. Now P2 has not completed its execution. So one more point here, P5 has not completed its execution, right? And so I didn't insert it. I should have inserted it. Okay, I have inserted it now. And also P2 has not completed its execution, so P2 should also be inserted into the queue. Fine. Now what we should be doing is, see, as of now only P6, P5 and P2 are inside the queue, right? And also P6, P5 and P2 are the only processes which has not completed its execution. Okay, fine. Now we will remove P6 and then schedule P6 till 15. So it will become 1. Okay. Then what we do is we will P6 has to still execute, right? It needs one time in from the CPU. So we will again insert P6. Fine. Now P5 will be removed and then it will be scheduled. Fine. It will run till 17 time units. Now so this will become 2. Fine. P5 has not completed its execution, so we will again insert it into the queue. Fine. Now P2 will be removed and P2 will execute for only one time unit, right? So it needs only one time unit from the CPU, and also P2 has completed its execution, so we don't need to insert P2 into the queue hereafter. Okay, fine. So what we will be doing is we will be removing P6 and then scheduling P6, and it will run till 20 time units. Fine. So P6 needs only one time unit, right? So we don't need to execute for 2 time units. So this will run only till 19. Okay. So it will become 0. Fine. Now the only process which is remaining is P5. We will remove it and then we will schedule it. Okay, so P5 will run till 21 time units. So this is how round robin scheduling algorithm will work. Okay, actually we have some advantages of using round robin which we will see it a bit later. Okay, fine. Just keep practicing. I think this is a bit tricky. Okay, it is actually very easy, but there is a high chance of making mistakes because we are dealing with the queue here as well, right? In the earlier scheduling algorithms, we are not having the queue, right? But if you practice, it will become very easy. Fine.